Hello everyone and welcome to Designing the Future. I'm Jim Anderton. I'll be your host for an interesting conversation about AI, the IoT, and much, much more. Now joining me is Remy Duquette. He's Vice President, Innovation and Industrial AI with Maya HTT Limited. Remy is head of the Industrial AI, IoT, and Data Center Clarity LC Global Business and Research and Development with Maya HTT. And Remy attended the International Space University after completing his master's thesis on MOST, Canada's first space telescope at the University of Toronto Institute for Aerospace Studies. Now, this followed his honors engineering degree at McGill University in Montreal. He's also been instrumental in designing and analyzing structural components of 5 successful spacecraft currently orbiting the planet. And in his youth, Remy was a short-track speed skating champion in the province of Quebec. The sponsor of today's program, Maya HTT, is a leading software developer and engineering services provider of multi-physics simulation, computer-aided engineering, CAD/CAM, and PLM. Maya HTT is a tech partner, software editor, and provider of Siemens solutions, and applies expertise in applied artificial intelligence, IoT, platform solutions, and low-tech, no-code apps across multiple industries. Remy, welcome to the program.
Thank you, Jim, for having me on the show.
Remy, you're a champion short track speed skater. For those who've not seen this sport, it reminds me of roller derby, except on the ice. So it's a very rough and tumble, elbows out kind of world down there. And there are those who say that the aerospace industry operates just like that, an elbows out, rough and tumble kind of world down there. It used to be an industry where it took a decade to get a product from off the drawing board and into the air at that point. Is that still true today? We've got a lot of software, a lot of technologies now at this point. Can you spend 10 years or half your career, trying to get an airplane off the paper and into the air?
I mean, unfortunately, as speed skating, speed is always increasing in technologies, whether it's a blade or a car or a spacecraft. Technologies are enabling us to go faster and faster. And so, in engineering, it's exactly the same as way back when with blades that were, increasing performance. Well, today, in today's world, we certainly have software tools that were, unheard of 5 years ago. So when you talk about 10 years, I can talk to you about the last 6 months even, and it's been increasingly different for engineering as we get new toolkits, new toolboxes to deploy and help us design in new ways. And yeah, so it's going to accelerate even more moving forward.
Remy, it's historically major industries like automotive, consumer goods, mass production industries, and aerospace have operated in silos, very different, mainly driven by production volumes, of course, so the production technologies are different. But the design tools originally started from the aerospace industry and worked the other way toward automotive and consumer goods. You think of the major original CAD platforms. Are we looking at a world, do you think, where are these industries coming closer together, or are we still going to see a big gap between the engineer that wants to make 1 million things and the engineer that wants to make one spacecraft?
Well, it's a very interesting question. I mean, from an engineering standpoint, I think those worlds have been getting closer together over the last couple of years. And the reason is, the technologies that are enabling them are, let's say, evolving to a point where both can leverage these tools in different ways. So, of course, the aerospace engineer has a slightly different time frame than an automotive engineer or a manufacturing engineer. But in the end, the toolkit that are made available to them are accelerating each of them in different ways. So if we look at, an aerospace engineer looking at designing the spacecraft, well, the spacecraft and the missions are becoming under shorter and shorter time frame. And you look at, launching rockets and having them come back on the planet and be reutilized. I mean, that kind of technologies is accelerating the pace of space exploration and access to space. So, of course, then it goes along with shortening the timeline for those space missions in the future. So those engineers now will be on a tighter deadline, but their margins of safety are still very, very narrow, right? An aerospace engineer is working with very, very tight margins. Most people might not know this, but the margins of safety there are very, very small, because every ounce of anything that you move as mass into space is costing you a lot of fuel and a lot of energy. So people may not understand the dynamic there, but it's pretty constraining for the engineers. Whereas in the automotive, it's been a little bit of the reverse factor where automotive industry has embedded more and more in electronics and AI. We'll talk about it a little bit later, perhaps, hopefully. But when you look at automotive industry, it's been transformed by other ways and accelerated in other ways by new technologies enabling cars to do different things and become a service and kind of a car as a service, if I can call it this way, where you have so many embedded technologies. Self-driving cars is one aspect, electric cars is another. And when you look at future technologies enabling more and more there, it's gonna change a little bit the way that the design and timelines are affecting these. But because of those two things, in both ways, they're shortening the timeline, and the technologies, yes, are getting them to be a bit closer in terms of two worlds and not separately. Aerospace engineers looking at bleeding edge technologies that are finding its way eventually into a mass production cycle that is very short term. So that those days are gone. It's really a much more fluid interactions and worlds between engineering for automotive or aerospace. Of course, the specialties are very different, but in the end, the timelines are becoming a lot closer than they ever were.
Remy, the aerospace industry were the first to use simulation as a development tool. But in the original way they did this, of course, was using physical artifacts, simulators. So you would sort of model your flight control laws or your anticipated flight control characteristics into the machine. The test pilot would climb out and say, I'm sorry, the stall spin characteristics are terrible. And you go back to the drawing board and then iterate again. But that form of simulation had a very expensive physical component in the sense of an electromechanical device that you're trying to study its behavior. Simulation today is virtual. And the implication is that we needn't spend millions of dollars to do it the way Boeing or General Dynamics does it at this point. Maybe we can reach down and the person making toasters can simulate the way the toast pops. Is this where this is going? Are we going to see simulation in every manufactured product?
Well, certainly, maybe not in every single product, but certainly in a lot more products than we've seen before. And yes, historically, simulation has been underutilized in many areas, especially in conceptual designs and other areas. And as it was the case also in the aerospace industry, as you say, we used a lot of prototyping that were very expensive, and because it was so expensive, we had to switch to a better way of doing things, and that's where simulation came in and helped in terms of virtual prototyping and reducing that cost. And so that enabled then optimization loop to automate the software and the simulation. And now we'll see the next generation really generative design and other new technologies that are coming about. At every turn there's new tools and technologies in the arsenal of every engineer's growing toolbox. And so I can see that it's not only using those technologies and simulation earlier in every product. That is definitely a big trend, and it's going to continue. I can't see that stopping. But it's also new ways for engineers, new tools to go beyond this, beyond optimization and beyond just the using virtual simulation. And we'll talk hopefully a little bit about how AI and generative design perhaps as a way to enable and augment the engineer's creativity to pursue different avenues that were probably explored a little bit less than in the past.
Remy, historically in aerospace and automotive as well, a big part of the design or development process would be to instrument a test article. So the number of data points you had available to you are limited by the number of strain gauges and thermocouples you could stuff into the airframe or into the chassis. And then either you had an onboard recording device or telemetry, and that data set hopefully agreed with predictions from the design engineering team. If it didn't, you went back to the drawing board. But AI promises a world in which you can be certain of the performance parameters. And if you do that kind of instrumented testing, it may only be to verify what you already know. Is this the future? Are we looking at AI as a way to be so certain that we're correct that we can reduce or eliminate that kind of actual real world testing?
Well, so in the end, you're hitting on very sensitive topics because there will always be, in my opinion, a need to validate. And it's true that AI promises to shorten and augment the capabilities of testing or real-time telemetry coming down from thousands and hundreds of thousands of devices instead of just having a one test specimen or a few test specimens that we can instrument and get feedback from an engineering perspective. So I think AI promises once we do harness more data from existing designs, then yes, I think we will have new powers and new ways through Industry 4.0 and IoT in general. The advent of those new technologies will provide more data to engineers. Now, of course, we can talk about cleaning of data. I mean, in every engineering project and manufacturing and Industry 4.0 projects we've been into, there was, a 50-60% data cleaning time that was required before you could actually leverage and harness that data in a proper way from an engineering standpoint to improve your designs and throw it in an optimization loop and augment your capabilities. So I think right now we're in this transition mode of getting access to data. It's not yet clean data. It's not validated data that we can safely use. So there is always that element of safety as well. And some designs that safety requirement or regulation requirement is a little bit less. So in those cases, you can probably do a little bit more of usage of that data. And from a statistical basis, it's probably fine, even if there's some level of data errors. But in many cases, you have to be careful as an engineer of how you're going to harness that data and make sure that the data you get is not biased. I mean, we've heard all these chatbots failures in the past. I mean, we can't do that from an engineering standpoint. I mean, putting out a product that will fail is just not acceptable. And so from an engineering standpoint, there are some checks and balances and validation that needs to happen in that process. But I believe, yes, it will bring about AI and IoT and collecting and harnessing that data from not just those few test specimens, but really a wide range of product data that are out there, whether it's in your shoe or your toothbrush or your coffee cup today. The sensors are spreading everywhere, and that will enable very, very fantastic feedback to the engineers and the way that they go about their work.
Remy, you mentioned the cleanliness of data, clean data. That I think not enough is discussed about this issue. In the traditional, analog data reduction world, you had a bunch of inputs basically, and if you saw a sudden spike in the expected waveform, you often assumed, well, that's a transient or it's an artifact of the of the instrumentation, and you either analyzed it deeper or you ignored it and moved on. So it was an intuitive process at this point. But now with the IIoT, you can instrument everything at an unprecedented level. So instead of 200 channels of data, you could have 20,000. So what are the implications for determining whether or not you have clean data? I mean, can you be overwhelmed by information and have difficulty with this?
Well, so there are really two approaches. And in terms of clean data, we have to kind of set back. And in the context of having millions of devices and a frequency of data collection that is huge, the data cleanliness issues are not as big. I mean, they're big in the sense of there can be bias in the data, and it will be very difficult for you to find out until it's too late. So, and the chatbot issue is just as an example, right, of how, they collect millions and millions of voices and different things, and then they turn into a lexicon of words and strings of sentences that you can use in different contexts. And it can go awry very quickly if the data that it was learned from is biased in the first place. And you only unfortunately figure this out a bit later. So in the context of real-time telemetry data that most engineers would leverage for their designs or their new designs for improvements or whatnot, it's a little bit different in the sense of you have a little bit more control in the first place. Now, if you have, but on the flip side, you don't have millions of devices today. You might have a few thousand, and if you're lucky, tens of thousands of devices. And in those cases, then you can start, you have a middle ground where you have to do a certain level of cleaning of the data. And when we say cleaning is, the outlier type of events, you don't want to leverage those if you're going to use those in an optimization loop that automates some of the generative design or adversarial, neural networks that can, learn from these things. So you have to be a little bit careful. But so the cleanliness of data has various facets too. In some countries, you're going to, just as a simple example, temperature will be Celsius versus Fahrenheit. Well, an AI technology may or may not realize that the temperature profile is recorded in Celsius versus Fahrenheit, and you have these deltas that are built into your data set. And on a million data points, if they come from multiple countries and you haven't really aligned the engineering units, for instance, a very simple data cleaning, right? I mean, this is part of the data cleaning. It's, reconciling the engineering units. And those very simple data cleaning steps and validation steps are what I'm talking about. And once you've done those and you've made it, somewhat, you remove all the major outliers, the things that are way out there, and you've actually normalized the engineering units, then in today's world, you have access to you're really a gold mine of new information that you can turn into, useful data points for your engineering team and for your design, and even put some automation layers that we didn't have access before through AI techniques, whether it's deep learning, reinforcement learning, depending on the field and what you want to achieve. These new capabilities and technologies bring wonderful results, and engineers are embracing those results, of course. So it's yeah. So the data cleaning is very dependent on the amount of devices and data points and frequencies and the distribution of it, like countries versus engineering units and all this. So it's a little bit more complicated than people think of. Oh, it's simple. You just clean the data. Not straightforward.
We're entering the 2020s. We're seeing the confluence, I think, of several interesting technologies all at the same time. One is this ability with the IoT to have embedded sensors in everything. I mean, you're from the aerospace industry, you know how that worked. The test articles were heavily instrumented, they were usually overweight, and the flight articles actually, all that stuff was ripped out, basically. So you tested one unit, you built to that design, and then crossed your fingers, everything is fine. Now we live in a world where it might be possible to have a heavily instrumented so-called test article, which is the same as the production article, constantly feeding information then back to the design team. So the era where you design something, complete it, release it, and then move on to the next project, is that going to be replaced by a new era where you iterate designs through the entire life of the product? Are we going to see a time when you spend your whole career designing and constantly redesigning the same aircraft, for example?
Yeah, I think we are getting close to that. Maybe not aircraft per se, because the design timeline is still a bit longer, but certainly for many other devices and products, whether it's pumps or heavy duty machinery or things that can evolve fairly rapidly in terms of not having to be retested. Like an aircraft, has also a test sequence and approvals from regulations that are pretty tight. But in other markets and industry, absolutely, the fact that you are getting this telemetry hooked onto the product, not just the test product, but the actual product itself, brings about two things. One, most companies are starting to monetize that data, right? The data that is in production and used in operation can bring other benefits to the company. So if you think of heavy machinery, the preventive maintenance programs and the after sales business models that can come along will also bring engineering change in terms of, the design and the simulation is not stopping after the first design cycle. You are constantly getting to that point where you get new data and you can improve it, and you can improve it for two reasons: either for your own after-sales services, which means you have a data-driven new business model in your company. So as engineers, you're part of now the revenue generator of the company, which is a new mode of thinking for engineers in many instances in many markets. And so that's one way. And then the other way, yes, it's to improve a design for the end users purely. And yeah, those telemetry, the additional telemetry that you can gather and harness clearly today. And we've seen many examples especially in the manufacturing domain right now, even just before it hits operations or usage by the general population. In the manufacturing setting, where you have discrete manufacturing, you're collecting a ton of data now on the machines themselves that are manufacturing your goods. And we've been able to harness that data and improve constantly on a daily, weekly, monthly basis, the manufacturing process to make it very efficient, and learn from the manufacturing data and use that. I call this industrial AI, which is really a focus of ours at MyHTT. And really, this is where we've seen a lot of early benefits for engineering and manufacturing companies.
Remy, we keep talking about various aspects of AI in engineering in general now. We're using AI in the form of generative design, advanced simulation early in the design process now. So the machine is helping us actually render the product in the first place. Then the machine is helping us virtually test it to see if it's going to work, see if things fit together. But at the back end, we're analyzing vast amounts of sensor-driven data to determine performance after we've actually built the product at the same time. Vast quantities of data. Are we going to need AI to actually help us make sense of what we're looking at? Because when you flood an engineer with tens of thousands, hundreds of thousands of data points at that point, it must be very difficult to actually pick out something significant from that river,
Yes, and we are harnessing a lot of data, and if you just do a data dump in front of an engineer, it's going to be a disaster. And so yes, there are tools today, absolutely, that are being built around even explainability of some results of AI. Right, that's one thing as well. So not just explaining the data, but explaining the result of an AI algorithm that's using that data. So why it came to that conclusion or that design or that simulation results or the reinforcement learning, the control, why did you increase the temperature and lower the speed of the fan? So all of these things are coming to, I'd say, a head right now in terms of explainability is currently under research. It's very much a research field at the moment, but certainly it is an enabler that is required to move even faster in the future. But I've seen some, and we've used some early tools to use to explain the data and explain what is happening on the result of an AI algorithm on the outset. And yeah, these are fantastic new tools, and yeah, clearly that will be required for any engineer to really comprehend what's happening from the data and be able to help the engineer interpret the data. The data itself and the AI, will do a great job, but you need the creativity and the understanding of the engineer to be able to actually leverage and take actions on this at this stage. So it's not just a magic wand, right? That the AI or the data will all of a sudden bring about new amazing design. No, there are engineering constraints and very complex things that AI today is not capable of enabling. So I'm sure if we talk way long term in the future, then maybe that's possible. But today and for the foreseeable future, engineerings are being augmented by data, are being augmented by AI, and that's what we're seeing as a big trend.
Remy, many aspects of production engineering involving designing things that use suppliers who supply assemblies or components externally, and you integrate those into your design. Not everything is custom. And I've been in that world where in the automotive industry where frequently purchasing changes a vendor, the vendor supplies a part which is perhaps electrically equivalent, but functionally slightly different, that requires a redesign of an assembly or a part, and then there's revision control issues, and then problems ripple through the entire process. And historically, the PLM side of the business and the operations side of the business, even the supply chain side of the business, they didn't talk very much to the engineering side of the business as well. And you had inevitably these sort of conflicts, these frictions that cost money. Is with AI in harness now, are we going to see, do you think, sort of a blending of those roles? Are we going to have like one universal AI software package that runs an entire engineering business?
I wish, but that's utopia today. I think what we are seeing though is actually the silos being broken because the data and the AI has to encompass more and more data types and cross fields and even within an engineering community, you have mechanical, electrical, and many other manufacturing engineers and control engineers that typically have operated very much in silo and in sequence. And now, because of the agility that is being required, right, we have to merge those people together so they can be agile and leverage the same data and understand the same data in different ways. And that includes external suppliers. It does include, the encompassing this. If you look at Industry 4.0, the made to order does include your internal manufacturing, but it also includes external components, right? So there is a very much a connectivity required here that is new for many people, but is bringing people together and augmenting groups and breaking those silos. I don't see an AI being all-encompassing and able and capable to understand all the complexity behind all these walls. But on a task and optimization basis, absolutely, right? These are augmenting each of these different groups in different ways. So for the foreseeable future, I think AI will help breaking those silos and bring those people together and making them more efficient and be more agile in the way they do engineering and deploy their designs. But I don't see it as one big AI brain that comes in the shop and says, okay, here's where you're wrong, here's where you're right, and engineers out. That is certainly not going to happen in any short or medium time frame that I can think of.
Remy, you mentioned the silos, and the more complex the engineering project, the more the need for specialization. And historically, that meant many specialist engineers and designers who had a particular area of expertise that had to collaborate. So the pure design engineer might design perfection. And then, of course, then the manufacturing engineer says, well, we can't produce that cost effectively. So then the negotiation begins. Can you relax that tolerance? Can I open up that radius? That sort of horse trading that goes on. With AI and advanced simulation and generative design doing a lot of that thinking up front, is that going to go the other direction? Are we looking at a future 50 years from now where there's no such thing as a manufacturing engineer, a pure design engineer, or even a civil engineer, mechanical engineer? Will it just be an engineer, a creative person supported by machines?
Well, certainly that is a big trend. I mean, I've had a lot of discussions and even keynote speaking presentations where I've talked about the generalist engineers versus specialist engineers, and I would tend to think that yes, by and large, creativity and creative engineers, people that have innovation thinkers. Enabled by AI technologies like generative designs or all sorts of other really fantastic new technologies, genetic algorithms and evolutionary type programming. So all of this is augmenting those engineers. But you're right, the specialist engineers, and I have this cartoon in my head because as an aerospace engineer, we had the structural people, the antenna, the power, and there's this fancy cartoon that you show kind of the ultimate design that everyone would come up with. and as a structural engineer, you'd have like trusses everywhere and everything would be massive and very solid and couldn't move a micro millimeter or anything. But and then you have the antennas, you'd have like 5 different redundant antennas on different ways with different wavelengths to make sure you never lose them. So, depending on how you look at it at this stage, because you can bring that specialization down to, you have margins and you have simulation tools that you can leverage. So it reduces a little bit the need for specialists. Now, I'm not saying that they're not going to be needed at all. There are some areas where clearly a specialization is needed. Like, if you look at a nuclear power plant, a nuclear engineer is a very specialized engineering field that it will be required moving forward. There's no replacing of that, specialization. But in terms of, mechanical, electrical, the micro, mechanical kind of combined with electrical engineer, that kind of combination will become more and more common. And as a generalist, it will become more and more common.
Remy, I see by the clock of the wall, we're just about out of time, but I've got time for one more question. Now, with MyHTT, you work for a well-known provider, service provider, and solutions provider of all these things that we've talked about. But generically, if you're an engineering-driven firm that needs to go beyond just a simple CAD/CAM package and think about this kind of integration, what defines a good provider, a good vendor? How do you start the shopping process?
Well, certainly you have to look at, the gotchas are always in the integration. We talked about, these silos and the first thing you do need when you start looking at software with CAD, CAE, CAM type of software, and also control and, software in the loop type of capabilities, you have to look at a vendor that covers the integration of all these things, and not just a one niche vendor that will sell you maybe a 5% better tool, but that does only one thing really, really well. Well, today, engineers and AI can compensate for that 5% bit if you can integrate and be a lot faster to market. So looking for a partner, I would say, look at people that can integrate end-to-end, really integrate end-to-end. And there might be a few bits and pieces missing. And this is where my HTT partner can, come in and help fill those gaps to customize components that are needed along the way. But in the end, start with a solid foundation that has integrated pieces software already in the house, and then augment it with partners like us that can bring AI as a service, can bring additional customization on top, and make simulation and CAD and CAM a unified process and not just a siloed process.
Remy Duquette, MyHTT, thanks for joining me today on the program.
Thank you so much, Tim. It was a great pleasure to have a great discussion today. And the future of engineers, hopefully, future of engineering, hopefully, will be well served today.
And thank you for joining us, and see you next time on Designing the Future.